Code problem 1882 process tasks using servers. So for this example, we are giving this servers array, and we are also giving tasks array. So for the servers array, this means for each of the server, it's gonna have a weight. So for example, the first server gonna have a weight of 3, and then the second server has another weight of 3, and the third server has a weight of 2. Yeah, so this means for each of the tasks, I will always choose the smaller weight of the server. So for example, this task is 1. So this means I'm going to use a smaller weight. So basically this is a small task. Basically I want to use a smaller weight of the server. So this means I'm going to use the last server 2. So inside of the example, at second 0, so task 0 is added and processed using server 2. It means we're gonna use this server until second 1. So what does that mean? So this means if there's any tasks, so for the any task, for the first task, it's gonna be 1, and this task gonna be a queue. It's gonna be inside of the queue, and it has a sequence. So first we're gonna handle the first task, because inside of the tasks array, because this task is a 1. Definitely we're gonna use a smaller weight. So this means we're gonna use this weight 2. It means we're gonna use the server 2, yeah, until second 1. So this means from the first task it is index 0. So 0 gonna plus this task 1, so it's gonna equal to 1. Because from the beginning all the servers are free, definitely we can use all of them, but we have a priority. We're gonna use the smallest weight. Yeah. But if there's a tide, we're gonna choose the smallest index. So there's another priority queue. So it means the priority queue gonna first check the weight. So we're gonna use a weight, and then we're gonna choose a index. So if the weight is equal, basically we're gonna choose the earliest index. So this is the idea. Yeah. So let's just check the next one. At second 1. So this means here we finished, and then it's gonna be second 1. So at second 1, server 2 becomes free. Yeah, because this server just used 1 second, and then it finished. So at second 1, yeah, because at second 0 this is free, and it consumes 1 second, and then becomes second 1 and becomes free again. Yeah, at second 1 all the servers are free, but we're gonna choose the smallest weight. So the server 2 becomes free. So yeah, we can choose all of them, but we're gonna choose the smallest weight. It means we're gonna choose this server again. So task 1 is added, and so this means this is task 1 is added and processed using server 2. We're gonna still use this server until second 3. Yeah, what does that mean? Because this is index 1 at here, index 1 plus a 2, it's gonna be 3. It means until times 3 I will be free again. So here at second 2, what are we gonna do? So at second 2, task 2 is added. This is the task 2. It is 3. It's ended and processed using a server 0. Why? Until second 5. Yeah, so currently we have this task 3, but normally we're gonna use this server with a weight of 2, but because it is currently it is used until times 3, we can use it again, but currently it is at time 2. Basically it means we cannot use this one. So we're gonna choose the server 0. It means this is 3, the first one, until second 5. So until second 5, then it will become free again. So at second 3, server 2 becomes free again. We should know that. And task 3 is added, and this is the task 3 is ended and processed using server 2 until second 5. And similarly at second 4, so this task 4 is added, so this 1 is added and processed using server 1 until second 5. Yeah, because here for server 1 until second 3, yeah, let me just check. Server 2 becomes, yeah, so we're gonna use the server 1 until second 5. Let's just check when server 1 becomes free. server 2. Yeah, but definitely we're gonna use this server 1. So until 5, because we never used this server 1. So at second 5, all servers becomes free. So which one we're gonna choose? Definitely we're gonna choose this server 2, with a weight of 2. It's gonna be the last server. This is server 2 until second 7, because it's gonna be at time 5. It's gonna plus because this is gonna be 0, 1, 2, 3, 4, 5, index 5 plus this task 2, which is gonna be 7. This means at second 7, it's gonna become free again. Basically, we're gonna yeah, we can use it. So how can we solve this problem? Definitely, we're gonna use the priority queue, and for the priority queue, we're gonna use this weight, and yeah, basically this weight we can use as a server. Yeah, so this server is a weight, and we can use the index. Yeah, normally we're gonna use the index. So this is one of the priority queue. So we're gonna define a priority queue. So inside it's gonna be S and I. S gonna be this server, and index I gonna be index of the server. Yeah. So this means all the servers. This priority queue means all the servers will be available. This means the available servers. So give me a task. So for example, give me a task. I'm gonna choose the server. So all the servers will be inside the priority queue. So this means all those servers will be available. So that will be inside the priority queue at this task. Because while I goes to this task, definitely I have a time, and for this time, definitely I can choose. Yeah, for this time. So less than or equal to this time, every server will be inside of the priority queue. This means I can use it. So what if the priority queue is empty? This means I cannot use it. So I'm gonna prepare another priority queue. It's gonna be used priority queue. So this used will be a time and a server and I. So the time is also calculated according to here, the t plus the task j. So this means at this time, definitely I can put it yeah, at this time definitely I can put it, I can free it and put it inside the priority queue. Yeah, so sometimes if it is inside the priority queue, I can use it. If it is not inside the priority queue, what I can do? I can use the used array, because inside the priority queue it is empty. Yeah, so no servers can be used. But there are still some servers inside the used array. So inside the used array, after some time, definitely I can use it. So I'm still gonna choose the priority queue. Maybe here at time 5, but this t, the smallest value is 10. But I can still choose this 10. Definitely I will not choose 11 or 12. I will choose this 10, and I will choose the index I. And then I will just update the time. So this t will plus the task j, and I will still put it inside the used priority queue. Yeah. So let's just try to solve it. So we're gonna prepare a priority queue, and then we're gonna check the servers. So for IS enumerate the servers. So this servers, this priority queue is just for the available servers. For current task. Yeah, and then we're gonna use the heaps. So we're gonna push the server and the index. So this S and index. So this S means basically weight. We're gonna push the weight and the index. So inside the priority queue. And because while we pop it out, we're gonna always choose the smallest weight first. If there's a tie, we're gonna choose the smallest index. So this is why we're gonna design this S and I. Yeah. We still need to have a used priority queue. So basically, it's gonna be the time, server, and the index. Yeah, I think that's for the preparations. Now we're gonna check the each of the tasks. So I'm gonna set a base time. So for this base index and tasks, enumerate the tasks. First of all, I'm gonna check the used array. So if used and used 0, 0 less than or equal to the base array. So basically, this means all those used servers will be freed and will be put inside the priority queue. Yeah, because this is the free time. The free time is less than or equal to the base time. So basically, all those used servers will be freed, and I can use it again. So this means I need to pop it out. So we're gonna use the heap pop with the used array, and it's gonna be 3 values. So time, server, and index. And then, as this is free, we need to use the heap push it to the priority queue. It's gonna be this server and the index. Yeah, this is not if. This is gonna be a while loop. Yeah, so while it is used and this small list value is less than or equal to the base value, I'm gonna pop it out and push it inside the priority queue. Yeah, so here gonna be a while loop. Now I'm gonna check if there's something inside the priority queue. So basically, I pushed everything inside the priority queue. Yeah. So if there's something inside the priority queue, first of all, I'm gonna pop it out. So it's gonna be the server and index, gonna be heap pop. It's gonna be this priority queue. Yeah. So if I pop it out, so basically this means I'm gonna use this one to handle the tasks, to handle my current tasks. Yeah, for this task. So I'm gonna put it inside the result array. So result is gonna append this I. So I also need to define a result array. So this is gonna be my final result. Yeah. Now, as I pop it out, so if I pop out any servers, basically this server is gonna be used. This means from here it is free, and then I'm gonna pop it out. This means I'm gonna use it. So I'm gonna put it to the result, and then I also need to put it inside the used array. Yeah, so it's gonna be a tuple, and from here it's gonna be base plus the task and the server and the index. Yeah, I'm gonna put this server with this index, and for the free time it is here. I'm gonna put this tuple inside the used priority queue. Yeah. So what if the priority queue is empty? But I can still use the used array because there are going to be some servers inside the used array. Yeah. So this means all the servers are gonna inside the used array. So I'm gonna pop it out. So I'm gonna use the heap pop with the used array. Yeah. So basically it is a time, server, and index gonna equal to heap pop with used array. And we also need to use this server and put it to the result. So it's gonna be this it's gonna be this index. Yeah, because basically the result, the return, gonna be an array of answers. So where answer J is the index of the server. So I'm gonna use the index of the server. So here is just the index of the server. So here I prepared the index of the server, and then I'm gonna use it. Yeah, this is also the index of the server. So I pop out from the used heap, and I prepared the final result, and then I still need to push it to the used server, because even if I used it, yeah, so I still need to push it to the used priority queue. So currently this time gonna be this t plus the task. Yeah, so here is the base plus the task. It is from here, but here I have this time t. Maybe it is in future, I don't know, but I want to use this t, so instead of the base. Yeah, because currently it is inside the used array, I need to use this time. So plus the task and server and the index. So finally I'm gonna return the result array. So there's a lot of coding. Definitely it's going to be a difficult problem. Let me just run it. As you can see, it works. Now let me submit it. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. And the time complexity, basically, it is n log n time. And yeah, maybe it is. Let me just check. So enumerate the tasks. So the task gonna be m. So here, what I put inside of the priority queue, so it's gonna be the servers. So it's gonna be m. Yeah, it's gonna be m times log n. So this is gonna be the time complexity, and the space complexity. Basically, we're gonna use O n plus m. I think we're gonna use the priority queue, and we're gonna use the use the array. Yeah, let me just think about it. So inside of the priority queue, basically it's gonna be all the servers, and inside of the used array, it is also all the servers, and the result is for the index. Basically, it is the length of the task. So the type complexity is gonna be n plus m. Now let's analyze this problem. So why this problem is difficult? Because first of all, there's a lot of descriptions, and for this kind of a description, it's really difficult to understand if I'm not familiar with what is a server. So some server going to become free, some server going to become used, but we can still use the free server and the used server. If it is inside of the priority queue, this means yeah, this server is free. If it is not, basically we're going to use it inside of the used array. Even this server is occupied. Maybe at second 4 is occupied, but after second 7, maybe this server is free again, even it is inside the used array. Yeah, but if all the time is less than or equal to the base time, so all those servers will be free, and I want to pop it out from the used priority queue and push it to the available server. Yeah, for this current task, and I want to push it to the available servers. I think that's all about it. Thank you for watching. See you next time.